Okay, this video is going to cover similarity in geometry. A couple things that you'll want to remember are that congruent and similar are not the same thing. Okay, we've talked about congruent a lot, and that means that the shapes are the same shape and size. So two triangles that are the exact same size, that means same angles, same side lengths, okay, or two rectangles that are exactly the same, okay. And the symbol for congruent, if you remember, is the equal sign with the little squiggle above it. That's congruent. Okay, when we talk about similar, they are the same shape, such as two triangles or two rectangles, and the corresponding angles are congruent, but the corresponding sides aren't necessarily congruent, they're proportional. Okay, and we'll get into more detail about what that means. The symbol you'll see for similar is just the squiggle without the equals. Okay, so that's the symbol for similar. Okay, you'll hear what's called the similarity ratio talked about, and that's a ratio of lengths of the corresponding sides of two similar polygons. Okay, so you get the sides that correspond to each other and figure out their ratio, and the ratio will be the same for all corresponding sides in those figures. Okay, that's what makes it similar, is that the sides are proportional. You can see these similarity ratios written as a fraction, like side A is to side B. Okay, it can be written like this, A and then the word to B, or even with a colon, A is to B. They're all read the same way, and they're all the similarity ratio. You'll sometimes hear this called, you'll hear the word scale factor, and we'll talk about that more when we do dilations in another video. Okay, we're most often going to be writing our similarity ratio as a fraction. Okay, and remember, proportions, you've dealt with proportions before, is a statement of equality between two ratios, and that's misspelled. Okay, so you have two ratios, in this case 16 is to 12, as 4 is to 3, okay, because we can reduce 16/12ths to 4/3. Those are equal, so it's a statement of equality, and these are proportional. Okay, when you have a proportion with a missing piece, remember you cross multiply to solve for that missing piece, and that's how we'll solve for missing sides of similar figures. Okay, the first thing that you'll need to know is how to check for similarity. Okay, you may be given two figures with the measurements and asked, are these similar? Okay, so we're going to answer that question for these three problems. So in this first one, you have two rectangles. Okay, you have to check, are the angles congruent? Okay, and if the angles are congruent, then you check to see if the sides are proportional. So obviously 4 right angles and then 4 right angles. So the angles are congruent from one figure to the next. Okay, and then you ask yourself, are the sides proportional? Okay, and we do that by setting up the ratio and seeing if the ratios are equal. So I'm going to look at the shorter side of this first rectangle. So out of 24 and 36, 24 is the shorter side, okay, and we'll see the shorter side here is 18. So we're going to set up our proportion. 24 is to 18 as, and see if it's equal to the longer sides. Are they the same ratio? 36 is to 24. And I'm not telling you they're equal, I'm asking, are they equal? So you can reduce both fractions, or if you have a calculator, you can just divide and get your answer, whether it's a decimal or a whole number, and see, do you get the same answer when you divide both of these? Okay, so 24 over 18, this will reduce. 6 goes into both of these. 6 goes into 24 4 times, and 18 3 times. Okay, and then the 36 over 24, 6 goes into both of these, but so does 12. So we want to use the highest so we can reduce it the most. So 12 goes in to 36 3 times and into 24 twice. So these are fully reduced, and are they equal? The answer is no. So that means these sides are not proportional, which means these are not similar rectangles. Okay? If they were similar, these ratios would be equal. This proportion would be true. So we're going to try the same thing for this next one. Let's look at the first check the angles, okay? So in a parallelogram, these are parallelograms, you need to remember that consecutive angles, the angles that are next to each other, okay, will add to 180. They're supplementary. Okay, so if we look at where the shorter side and longer side meet at the acute angle, okay, that would correspond over here to this. This is the acute angle, okay? And this would be the larger one. So if this was 100, that means this would have to be 100. And then you check, would that add to 180? Well, yes, it would. So those are supplementary. So yes, this would be 80, this would be 100. So the angles are congruent. So now I'm going to check the sides. Are they proportional? So I'll look at the longer side, 6. The longer side here is 24. So notice these aren't facing the same direction. This one has been turned, okay, at a 90-degree angle. So the first part, the first ratio I'm going to set up is 6 is to 24. Okay, and I want to know, is that the same as 5 to 16? And I'm asking myself, are those equal? Now notice I put 5 over 16, not 16 over 5. You have to make sure you match in the order that you're writing your ratio. Okay, so I went 6 to 24. That was the left figure to the right figure. So I have to keep that order, left figure to right figure. Okay, so now if I reduce these, 6 over 24 will reduce to 1/4. But 5/16 does not reduce any. So those, again, are not equal. So these are not similar. Okay, so let's check this third one. These are trapezoids, and we can see the angle markings are telling us that the angles are congruent, because we have 2 in this trapezoid with 2 arcs, 2 here with 2 arcs, and then 2 with 1 arc, 2 with 1 arc. So our angles are good. So now we check our sides. Okay, so 25 in this trapezoid is the shorter of the 2 bases. So the shorter of the 2 bases is 20. So I'm going to say 25 is to 20. And then I'm going to check the longer base. So 40 is to 32. And now here there's a third measurement, the legs, okay, of these isosceles trapezoids. And I have to check that as well, because all the sides have to be proportional. So I will do 18.5 to 14.8. Okay, and I want to know, are all 3 of these equal ratios? Are they proportional? Okay, so you can reduce these fractions, or realizing that this has a decimal in it, you can just divide it. 18.5 divided by 14.8 is 1.25. Okay, you can do the same thing here. 40 divided by 32 is 1.25. 25 divided by 20 is 1.25. So all 3 of these are equal. So yes, these are similar trapezoids. Okay, now we're going to talk about corresponding parts. We've talked about corresponding parts before when we did congruent triangles, okay, but now we're just talking about them in similar figures, any type of figure. It doesn't have to be a triangle, okay, but you have to realize they're not always going to face the same direction. The images may be turned or flipped, so you have to be careful when you're saying what is corresponding. Okay, so we're told that these are similar figures. We want to know which of these angles are equal, because the angles, remember, are congruent, so we can say that they are equal. And then we want to finish these ratios, okay, so that all four are equal for the side lengths. This has been flipped and rotated, okay, reflected and rotated. Okay, let's go ahead and do the two easy ones that are marked. So W will be to G. Those are congruent. So I'm going to go ahead on G and put angle W. Okay, and the two, V and F. So V is congruent to angle F. Okay, so if I were to flip and rotate this so that it's in the same direction, my obtuse angle that's left would be the T is to H. And that leaves U to E. Okay, and I know that I can put one arc and two arcs because these are parallelograms, so opposite angles are congruent. Now when we go to find our corresponding side lengths, okay, we start with HG. So we said H corresponded to T and G corresponded to W. T, W. Then TU is given here, and we know that T was H and U was E. The next side that's given is WV, and we can see that the W corresponds to G and the V corresponds to F. Okay, and then last but not least, EF. The E was congruent to U and F to V. Okay, so first I'm going to use the marks that are given. So the two arcs mean that angle A is congruent to angle X. Angle C has 1, so it's congruent to angle Y. And then angle B is what's left, must be congruent to angle Z. Now the side lengths, okay, AC goes from 2 marks to 1. So over here, 2 marks to 1 is XY. Okay, AB, 1 arc to none. I'm sorry, 2 arcs to none. So that would be XZ. Leaving CB, 1 to none, would be YZ. They actually want the similarity ratio, so they want us to solve and see what the ratio is. So we can use any of these three, it doesn't matter which one, and then we'll reduce our fraction. So let's just use our first. AC is to XY, and that reduces. 8 goes into both of these. 8 goes here twice and 3 times. So your similarity ratio is 2 to 3. That means the smaller side, the smaller figure, is 2/3 the size of the larger one.